Alright, so it looks like only one person has joined today. So anyway, I will be starting with the week's content. I will be anyway uploading this content on my YouTube channel. So those people who have unfortunately not joined today due to whatever reasons, they can look at it with the link that we will be providing. So I'll be starting now. Start. Alright. Okay, so welcome to the 8th tutorial, right? So it is week 8 tutorial of sorry, I think someone wants to join. Yeah. Alright. So welcome to the week 8 tutorial of the course Basic Electrical Circuits. This is an NPTEL course, and it is taken by the instructor Dr. Ankush Sharma. He is a professor in the Department of Electrical Engineering at IIT Kanpur. Myself, I am your tutor. My name is Mayank Anupam. I am a PhD student and a PMRF scholar, and I am also from the Department of Electrical Engineering at IIT Kanpur. Alright, so pardon my voice, by the way, for today I am not very well. Pardon my voice. Fine, so in week 8 you learnt about two-port networks, right? So this is probably the first time that you have seen something like this. So what is two-port network? It was said that a two-port network is a network which has two input and output. Basically there are two input and output ports, right? So in generally you have learnt about only one port network, where only current enters and current leaves. Only one current enters and it leaves. Now there are two port networks where you have two places where current can enter and leave, right? So this is two port network. Okay, so I'll quickly summarize what you have learnt in this week. So the very first part you learnt about the introduction to two-port networks. What is two-port network and what does it look like? You learnt about that. So mind it that two-port network is a very special case, right? So in general, a network can be n-port, where there can be n places where current can enter and leave. Okay, so two-port network is a very special case of that n-port network. Okay, so you learnt about different ways to analyze, or what do you say? Different ways to basically represent your two-port network, right? So if you are given a certain network, you need to find some way to represent it or analyze it, right? Some mathematical modeling you need. Otherwise, you will not be able to do anything with it. You will not be able to do any analysis on it. So for that we have certain parameters. Okay, certain parameters that people have defined certain parameters to analyze the two-port networks. And what are those parameters that you learned? Learned about impedance parameters. What are impedance parameters? It is simply a relation between the voltages and the currents. So basically, in this case, your voltage at both the ports are the dependent variables, and the current is the independent variable. Basically, you excite your two-port network using current sources at both the ports, and then you see what is the response of the circuit. Basically, by response I mean the voltages at the input and output, and that response is given in terms of impedance parameters. Similarly, you learned about admittance parameters, where the dependent variable became your current, and the independent quantity, which is something which you are using to excite your circuit, is the voltage source. Fine. We also learned about hybrid networks. So basically, this concept of hybrid networks, hybrid parameters came into picture because not all circuits are representable in terms of admittance or impedance parameters. The example that you learned in this week's videos was of a simple ideal transformer. So there you cannot represent it in terms of impedance parameters or admittance parameters. So you came across hybrid parameters. So this is simply relating the voltage at the first port and the current at the second port to the voltage at the current at the first port and the voltage at the second port. This is this is very easy. So these are all the standard definitions. You also learned about transmission parameters. So you saw that transmission parameters are nothing but they relate your circuit's transmission feature. They quantify your circuit's transmission feature. So like the example that was given in the lecture was about transmission of high power from the base station to different parts of the city or villages, right? So power is generated, electricity is generated at a power station, right? And from there it is being transmitted to various places. So that transmission is of interest to us, right? You need to see how much you supplied and how much is actually reaching to the end user. So that is something which is which is being understood by transmission parameters. That is being quantified by transmission parameters. They are used to understand how the input voltage and current relate to the output voltage and current. Okay. Finally, you learned about interconnection of networks and how basically you connected networks in different fashion: series, parallel, and cascade. And you saw what is the equivalent parameters for the whole circuit, the whole network. Okay, in terms of the individual networks parameters. So you saw that. Okay, so you saw that when you connect networks in series, their Z parameters simply add up to give the equivalent Z parameters. You saw that when networks are connected in parallel, their admittance parameters add up to give the equivalent admittance parameters. You also saw that when networks are connected in cascade, then their transmission parameters are multiplied. Basically, that will be a matrix multiplication, right? So you also saw that some parameters are easier to handle in certain conditions. Like if you are talking about series connection of networks, you should not go with transmission parameters or hybrid parameters or admittance parameters, because that will be complicated. So you should go with the Z parameters, because it is simply addition of Z parameters. Similarly, when you have parallel networks, in that case parallel connection of two port networks, then you can simply use admittance parameters, because that will be much easier to handle. They simply add up. Similarly, if you have cascade of networks, then you should go for transmission parameters, because they will simply multiply in that case. All the other parameters in this case will be difficult to analyze. Fine. Okay, so this was a quick summary of the week. Now let's move ahead to the fun part. It is solving questions. The first question that I want to solve is this one. Sorry. This is the first question. So answer is already given, but I would like you to try this question. This is the first question. I want to find the Z parameter, which is Z22. More specifically, the Z22 of this circuit. Okay, so let's go ahead with this. Fine. So this is the first question. Okay. Let's do it. Question 1. Sorry, wait for a second. Someone wants to join. Okay, yeah. Hold on. Sorry for my voice. One second. Yeah, so we would like to find the so the question is sorry, find the Z22 of the error circuit. Okay, so let's try and find it out. Fine, let's do it. So what is Z22? So you remember Z22 is equal to what? It is equal to V2 by I2 when I1 is 0, right? So basically this is the short circuit, not short circuit but open circuit. Sorry, not short circuit, open circuit. This is open circuit output impedance, right? This is open circuit output impedance, correct? So what is meant by this? Basically this is you have to connect a voltage source here, V2. You have to see how much current I2 is flowing from here, and in the this has to be done when this current here is 0. Basically this node, this terminal here has to be open circuited. This port has to be open circuited. So you see that this is already true. This is open circuited. So now when this is open circuited and there is no current flowing through it, this 5 ohm is useless, right? It is not. It is as good as saying that it is not present there. So basically there is only this V2 is, this current here is going to flow like this in this branch only. Also you see that this is a dependent voltage source here, and its value is 4 times I1. Since it is given that I1 is 0, so this voltage source will be simply 0, right? So this is a short circuit. So in that case, what will be the V2 by I2 or the impedance here? It will be simply a series connection of 10 ohm and 20 ohm, right? So it is 10 plus 20, 30 ohms. Is everybody okay with this? See, the circuit becomes the equivalent circuit here after, in this condition. Basically when I1 is equal to 0, the equivalent circuit becomes something of this kind. This is simply a 20 ohm resistor here, and this is 10 ohms, and then there is this voltage source V2. Okay, and you have to find out this I2, and V2 by I2, this, the ratio V2 by I2 is what? It is simply the impedance, right? It is simply the total resistance, the equivalent resistance is in this network. And since you see this is 10 ohm and 20 ohm in series, so this is simply 10 plus 20, 30 ohms. Fine. So I guess everybody is clear on that. There's no doubt here. Fine. So now let's erase this. It's looking messy here. Fine. So the answer is 30 ohms. Z22 is 30 ohms here. So now let's move on to the next question. Okay. So here in this question you have to find y12, the y parameter, and more specifically which y parameter? Y12. Let's see. Let's see this. Okay. This is question 2. Find Y12 in the adjacent network. Correct? Let's do it now. Okay. So what is Y12, by the way? What is Y12? So Y12 is what? Is equal to I1 by V2 when V1 is equal to 0. Correct? So it is short circuit. What? Transfer admittance between port, so not between, but let me be practically correct here, admittance from port 2 to port 1. So do you understand the meaning of this statement? Short circuit transfer admittance from port 2 to port 1. This is short circuit. First thing is short circuit. Why is it short circuit? Because you see here, you make V1 is equal to 0. At the first node, you simply ground it, right? You simply connect it with ground. This is short circuit. That is why it is short circuit. Now let us focus on the transfer admittance part. Why is this transfer admittance? What is simple admittance? Simple admittance is what? It is the ratio of the current and voltage at the same port, right? A simple admittance, general admittance that you have heard about is what? It is the ratio of the voltage, ratio of the current to the voltage at the when both are taken at the same port. Here you see the someone wants to join. Yeah. In this case, the voltage and the the current is taken at this particular basically the first node, basically current is taken at the first port here, but the voltage is being given at the second port. So that is why it is called transfer admittance, okay, or trans admittance. Okay, this is transfer admittance or trans admittance because the ratio of the current and voltage that is taken here to find the admittance, they are not at the same port. Okay, both are at different ports. That is why it is transfer admittance or trans admittance. Now from port 1, port 2 to port 1, why is it written like this? It is given from port 2 to port 1. Why? Because port 2 you are exciting and you are seeing the response at port 1. Okay, you are exciting at port 2 using a voltage source. This is the dependent, so the independent variable is V2 here. So you are exciting the port 2 using a voltage source. Okay, and then you are seeing what is the response here. What is I1 current flowing through this? So I guess that makes sense. That is clear now. Okay, fine. So now let us understand what will be the value of Y12. So okay. So Y12, as I wrote, I will write it again. Y1 is equal to I1 by V2 when V1 is equal to 0. Now you see this this voltage source here. This is a dependent current source here, right? Its value is 0.2 V1. Now what will happen to this current source when V1 is equal to 0? This will also become 0, right? This current source will be 0. What is meant by some current in this current source is basically making a current 0.2 V1 flow through this branch, right? In this branch a current is flowing which is equal to 0.2 V1. Now when V1 is equal to 0, this current has to be 0. What does that mean? There is no current flowing in this branch. Basically this is as good as saying that this branch is not there. This branch is open circuited, right? So this branch here is open circuited and there is no current flowing through this branch, right? So that is why, so now let me erase this and see. Yeah. So hence the I1 current that will flow here, since there is no, you have given a voltage source here, right? You have given a voltage source V2 here. Now this V2 would have contributed to some current if this current was not zero, right? Now there is if this branch is open, if there is no connection between these two this node and this node, then basically the current in this branch here has to be zero, right? So the equivalent circuit, when this condition holds, when so when V1 is equal to 0, the equivalent circuit will be like this. So you have this short circuit here, the first port, and then you have a 5 ohm resistor. Okay, after that there is an open circuit here, then you have a 10 ohm resistance, then you have a simple voltage source V2. Okay, and you are told to find the current, sorry, not this direction but this direction. You have to find this current I1. So you see that clearly there can be no current flowing through this because there is no excitation given in this part of the circuit. So I1 in this equal to 0. So that is why this implies Y12 is equal to I1 by V2 when V1 is equal to 0. This also has to be equal to 0. Siemens. 07. Fine. So the answer in this case is 07. Anyone, any doubt, or everyone is clear with this? Oh, so I guess no response means everyone is clear with this. Let's move forward. You see that answer is 0 Siemens. Yeah. So here we have to find Y22. Okay. So Y22 in this network. Let's do that. Question 3. Here you have to find Y22. Okay. Find Y22 in the adjacent. Someone wants to join the meeting. Let's see. Adjacent network. What is Y22? What is Y22? It is equal to I2 by V2 when V1 equal to 0. Correct? It's equal to I2 by V2 when V1 equal to 0. And what is it called? It's called short circuit output admittance. Again, the terminology you should understand. Short circuit because you are short circuiting the node 1 voltage. Okay, you are short circuiting the node 1. Sorry, not node 1 but port 1. You are short circuiting port 1 here. And output admittance because this part here is this part here, this admittance here is the ratio of output current to output voltage, right? Generally you follow this convention that your input signal comes from left and output is towards the right? So since this output here is V2, so and you are taking the ratio of I2 by V2, which is admittance, so you call this as output admittance. Fine. So now the Y22 parameter is equal to I2 by V2 in the condition that V1 is equal to 0. So basically, how will the circuit look when V1 is equal to 0? Let's draw this equivalent circuit. So this will be short circuited here, V1. Then you have a 4 ohm resistance here. Then you have a dependent voltage source. its value is what, 0.1 V2. Fine. Now you have an, sorry, now you have a current source here in this direction. Its value is 20 times I1. Now you have a 10 ohm resistance like this, and this is your output port. Okay, so here you have to connect a voltage source called V2. You have to find out what is I2. So for simplicity, we just have to find this ratio, right? I2 by V2. We just have to find this ratio. So I'll just make this V2 equal to 1 volt, and we'll find out what is I2. The value of I2 will be same as I2 by V2, right? So I2 by V2 is equal to what? I2 by 1 volt. Same as I2, right? That is why I have written it like this. For simplicity, I'll just assume that V2 is equal to 1 volt. Okay, so this is the equivalent picture, right? So this is also ground, these two are connected together. Okay, so what will be the this ratio when 1 volt current flow, 1 volt of voltage source is connected? What is I2? So how do you find it? You find it using circuit analysis, right? So this is grounded here, right? And what is this? This is I1. This current is 20 times I1. So you have to find out what is this I1, right? So for finding out I1, you need to find out this voltage source, this dependent voltage source. It is equal to 0.1 V2. V2 we have given as 1 volt, right? So this voltage here is become 0.1. So the new picture will be like this. This is 4 ohms. This is minus plus. And you have to find out this current, and this is what, 0.1 volt in the direction that it is given, minus here and plus here. So what will be the I1 in this case? I1 is equal to 0.1 divided by 4, right? So what will it be? Let's leave it like this only for now. This is this much of ampere, right? So I1 is this much. Now let us try to find out I2 here, right? So if you apply KCL at this node, right? So what will be the KCL? KCL at, let's call it node 2. Node 2. This gives what? Sorry. Yeah, KCL at node 2. What will be KCL at node 2? It will be I2 equal to what? V2 by 10. Basically I2 should be equal to current flowing through this and flowing through this, right? So I2 should be V2 by 10 plus 20 times I1. So I2 is equal to V2 is equal to what? It is equal to 1 volt. We have taken it as 1 volt. So this is 1 by 10 plus 20 times, sorry, this is, yeah, 20 times 0.1 by 4. So I1 value I have replaced from this, right? This is 20 into 0.1 by 4. So what will it be? 0.1 plus 20 into 0.1 becomes 2, and 2 by 4 becomes 0.5. So it becomes 0.6, right? Ampere. So your I2 by V2 when V1 equal to 0 it is equal to 0.6 ampere upon 1 volt, which is 0.6 siemens. Okay, this is so this is the answer in this case. It is equal to 0.6 Siemens. Fine. So any doubt in this question? Hello, any doubt in this question? Because no response means again there is no doubt. Fine, so let's go ahead. Let's move to the next question. So yeah, so this is 0.6 Siemens. Fine, let's go on to the next question. Determine the transmission parameter C for the below circuit. This is the circuit here. This is not below, but this is adjacent. Okay. So let's find out transmission parameter for this circuit. This is question number 4. Fine. So we have to find transmission parameter C. So what is C equal to? Okay. So C is equal to what? C is equal to I1 by V2, right? When I2 equals to 0. Correct? So yeah, it's again the same open circuit. What it is? Open circuit. Transfer admittance from port 2 to port 1. Okay, I guess by now you are very comfortable with the terminology here. The terminology that is written here is consistent with what I have been explaining till now. Fine. So what does this mean? You have to open circuit the second port, right? I2 is this one. This is I2. This is I1. This is V1. This is V2. So I2 has to be equal to 0. That means what? This part here has to be open circuit. Basically, it should be remaining the same. That it is the condition that it is in right now has to be maintained, because right now there is no current flowing through this because there is nothing connected here, right? So this is open circuited at present, and it has to be left open circuited. And then you have to find out what is the ratio I1, this current here. So this current I1 here divided by the voltage V2 here. So you see that in this case you will have to proceed with a slightly different approach. Okay, so in this case you cannot generally what happened was that the denominator here acted as an independent source, right? So you would apply a voltage source here in general like this, and then you will find out what is current I1. But that you cannot do here because it is very clearly mentioned that this current I2 has to be equal to 0. This current I2 has to be equal to 0. That means there has to be nothing connected in between these two nodes here, or basically at the second port you cannot connect anything, right? So what should you do here? You do a slightly different thing. What you do, you add a voltage source here at the first node. Okay, so let me explain what I am saying. Add a voltage source V1 equal to 1 volt at node, not node but port, port 1. Okay, so let's see how will the equivalent circuit look like. So the equivalent circuit in that case, after that the circuit will transform in this manner. So you have a voltage source here, which will be equal to 1 volt, or let's just call it as 1 volt. Is equal to 1 volt. Then you have a 1 ohm resistance. Okay. Then you have a 2 ohms of another resistance. Then you have 1 ohms here, 1 ohm here, and then there is a dependent current source like this, 4 times Ix. Okay. And what is Ix? Ix is the current flowing in this branch, right? Then you have this port here. This ground, common ground, and this is V2. Okay. So what you have to do now, you have to simply find out what is V2 and what is this current I1. And in this case, then after after you do that, you will find the ratio I1 by V2. Okay. So let's do it. So you see there are two nodes here, right? This is one node. Let's call it as Vx. This is V2. This node, let's call it as V2. The voltage here. This node voltage here is Vx. So you have to write two KCL equations, right? At these two nodes, this Vx and this V2 here. Let's do that. Okay. So KCL at this node here will be how will the KCL look like in this case? So the voltage here is 1 volt. So it will look like 1 minus Vx. So basically this current I1 is equal to 1 minus Vx by 1 is equal to Ix, right? So now let us write the KCL. KCL at node Vx. It will look like this. 1 minus Vx upon 1 plus, so this current is entering this node here, and this current is in this direction, that is leaving. So Ix is equal to what? Vx by let's write all the current that are entering in this node. So this current is entering, right? V1 minus Vx. Yeah. So this current here is V1 minus Vx by 1 ohms. So this current is entering. And what is this current which is entering at this point? It is equal to V2 minus Vx by, this is V2 minus Vx by 1 ohms. And this should be equal to what? Ix, which is Vx by 2 ohms, right? Okay, so from this what you will get? You see, this is Vx and Vx, this is minus. So V2 minus 2 Vx is equal to Vx by 2. This becomes 2 V2 is equal to 5 Vx, right? V2 is equal, so Vx is equal to what? Vx is equal to 2 V2 by 5. So where is this? This becomes, let me see. So Vx is equal to 2 V2 by 5. Am I right? There is no calculation mistake, right? So this is 2 V2 and this 2 into 2 is 4 Vx plus 5 Vx. 2 V2 is equal to 5 Vx. Yeah, there is no calculation mistake. This is the first equation, right? From here you get a relation between Vx and V2 like this. Okay. Now you can find the second equation through this, right? So you already see that this current here is KCL at node V2. Guess what? It's equal to what? It's at this node, you see the current is V2 minus Vx. V2 minus Vx by 1 has to be equal to what? 4 times Ix, right? The current here is the current source. This current has nowhere else to go. It has to only flow here because this current here is 0. The current that is flowing through this current source has to flow in this branch only, right? So V2 minus Vx, the current that is flowing here, V2 minus Vx by 1 ohm, has to be equal to the current that is being supplied by the current source. Fine, so Vx is already known, right? V2 minus Vx is equal to 2V2 by 5, should be equal to 4 times Ix. So what is this? This is 3 V2 by 5 is equal to 4 Ix. Let's bring it down, because this will be confusing for everyone. Someone wants to join. Yeah, cool. So this is yeah, so this is like this, right? So from this you get what? So let's copy this also, otherwise you will not this figure here. Yeah, so yeah, so now the current here is what, the relation between this. So here you get, from this you get what, you get Ix is equal to 3 V2 by 20, correct? This much of sorry, yeah, this much of amperes. Okay, now what you had to find, you had to find the relation between I1 and V2, right? I1 and V2. So you also have to find I1. And what was I1? Do something about it. Okay, cool. So what was I1 in this figure? You see, I1 is equal to what? I1 is equal to 1 minus Vx by 1 ohm, right? So I1 was equal to 1 minus Vx by 1. So 1 minus Vx. What is Vx? Vx is equal to 2 V2 by 5, right? So 1 minus 2 V2 by 5 is equal to what? 3 V2 by 5. Someone wants to join. Okay. So I1. So I1 by V2 from this, what you get? You get 3 by 5, which is equal to 0.6, isn't it? So is this right? So people who are there, can you tell me? Are you getting the same answer? Are you trying this, by the way, at your end, or is it only me who is trying here? Yeah. So what is your answer? Anyone did anyone try? Anyone else try?
नो सर, मैंने तो थोड़ा लेट से ज्वाइन किया तो मैं
Okay, fine. So can you try it now again? You have to find I1 by V2, right? So C parameter is what? C is I1 by V2, isn't it?
यस सर.
Yeah, so what it will be? So in this case, how will you find out? So I was saying that you can simply add a 1 volt. So here you have to add a 1 volt of voltage source, and then you have to find out what is the voltage relation between this I1 by V2. Okay, when this I2 is equal to 0. So can you do it now?
सर वन प्रॉब्लम ये था सर कि जब हम लोग डिपेंडेंस सोर्स सर्किट को डील करते हैं तो मेरा थेवेनिन रेजिस्टेंस नेगेटिव भी आ सकता है.
हाँ जा सकते हैं।
तो अगर मुझे कोई सर्किट में कोई रेजिस्टेंस के क्रॉस हमको करंट निकालना हो और मेरा थेवेनिन रेजिस्टेंस अगर नेगेटिव में है तो मुझे उससे पॉजिटिव लेके चलना होगा सर कि
नहीं नहीं
नेगेटिव
नहीं, नेगेटिव ही।
नेगेटिव में लेके चलना होगा
हाँ,
सर।
जो जैसा आ रहा है वैसे ही आना चाहिए।
ओके।
ओके। Yeah,
यस।
so let's review this. I think I have made some mistake somewhere in calculation, so let's review this. The answer is not supposed to be 0.6. Fine, so let's review. So at the first KCL at Vx, this node here, what will it be? 1 minus Vx, this is like this, 1 minus Vx by 1 is I1. Okay, so 1 minus Vx by 1 plus the V2 minus Vx by 1 ohm again is equal to Vx by 2, right? Is equal to the current entering at this node should be equal to the current leaving this node, should be equal to Vx by 2. This is right. So 1 minus Vx, 1 minus Vx, V2 minus Vx. Oh shit. Okay.
वन मिस हो गया सर।
One miss over. It's unfortunate. Okay, fine. So let's do it again here. Yeah, so now it is correct, right? So 1 plus V2 minus 2 Vx is equal to Vx by 2. Yes, this is right now. So 2 plus 2 V2 is equal to 5 Vx. So Vx in this case becomes 2 plus 2 V2 by 5, right? Yeah,
यस सर।
okay. KCL at node V2. V2 here is 4Ix is equal to V2 minus Vx by 1. And let's erase this whole thing here because this is just very wrong. So this is what happens when no one listens. Okay. No one is paying attention, then I will make some mistake in the heat of the moment and that will simply go on. This was just a waste of time. Yeah, so V2 is V2 minus Vx. Vx is what? 2 plus V2 by 5, right? So it is
यस।
equal to 2 plus V2 by 5 is equal to 4 times
टू
Ix,
वीटू
right?
सर। 2 + 2 वीटू सर।
Yeah, 2 plus 2. Ah, yeah, correct. Thank you for correcting. Fine, so now what will it be? 5v2 minus 2v2 is 3v2 by 5 minus 2 by 5 is equal to 4ix, correct? So
यस।
you get ix is equal to 3v2 by 5 minus, or 20 rather, minus 1 by 10, correct?
यस।
Right. Now you got ix. Just erase this everything here. This is wrong. Now you want to find, now we have what? I1, we have to find V2 by I1 by V2, right? So there is a relation here which is equal to 1 minus Vx is equal to I1, right? So here you see this particular equation here, 1
यस।
volt minus Vx by 1 is equal to I1. So this is what it is. Vx is equal to what? We have found out right now, yes? Vx is equal to 2 plus 2v2 by 5 is equal to I1, correct?
यस सर करेक्ट।
So what will it be? 5 minus 2 is 3, but 5 minus 2v2 by 5 is equal to I1, correct?
यस सर करेक्ट।
Okay. So from here you get what? Nothing here. So this is another equation here. It's called 2. Cool. Now you have to something is wrong. I've done some mistake somewhere. Should not be like this.
नो सर, ऑल इज तो करेक्ट, सब सही है सर.
I've done some mistakes in there. Fine, so let's review once again. 1 minus Vx is equal to I1. This is right. 1 volt minus Vx is equal to I1. Vx is equal to 2 plus 2 V2 by 5. It's correct because Vx is equal to 2 plus 2 V2 by 5. 1 minus Vx by 1 plus V2 minus Vx by 1. Yeah, so let's find out V2 now. Okay, this is one equation and this is the second equation. In this I have to replace Ix, right? So what is Ix? So Ix is equal to this here, right? So yeah, so right now I've got one equation, right? So I have to also find V2. So what is Vx? Ix is equal to V2 Vx by 2, right? So this is equal to Ix is equal to Vx by 2. And what is Vx? Vx is equal to 2 plus 2V2 by 5. And whole of this divided into 1 by 2. This is equal to 3V2 by 20 minus 1 by 10. Cool?
यस सर, यहाँ सही है.
Yeah. Now it is equal to what? It is equal to 1 by 5 plus V2 by 5 is equal to 3V2 by 20 minus 1 by 10. So you get what? You get what do you get here? 1 by 5 plus 1 by 10 becomes 3 by 10 is equal to 3V2 by 20 minus 3V2 minus 4V2 by 20. Someone wants to join. Okay. So this is equal to what? So yeah, so I am right. I have not done anything wrong, right?
यस.
6 is equal to minus V2. So V2 is equal to minus 6 volts. Okay. So if V2 is equal to minus 6 volt, I'll put it here and I'll see what happens. So V2 is equal to minus 6 volts.
तो
I'll
आई वन
find
इज
out
इक्वल
what
टू
happens. What is I1?
3 सर.
3 amperes. So what is I1 by V2? It's equal to 3 ampere by 6 volts minus 6 volts. Becomes 0.5 minus 0.5 Siemens. Correct?
यस.
Yeah, so that is the answer. Minus 0.5 Siemens. Okay. So yeah, so this is the answer of this question for fourth question. Okay. So this is what is also written here. So there was one more question that I wanted to discuss but I couldn't, so I will discuss it in the next session. Okay, so time is already up. So I guess you'll have to join the next session. This is from 7 o'clock, right?
Yes.
So I made some mistakes in the calculation, which is why I was unable to complete. So anyway, that happens. Okay, so thank you for joining. We'll meet in the next session. Okay.
Thanks a lot. Thanks a lot. धन्यवाद.